What's going on, guys? So this video is kind of a continuation of my last video, but it's also kind of a standalone video. All the different parts in this video, you can actually check out the progress bar so that you can jump throughout different sections of the video using YouTube's chapter feature. I'm going to go through all the things you have to change a little bit later on the wire harness so that it can be run by the Haltech. In the last video, just really quickly, basically all I did in that video was I plugged in an automatic ECU to my factory manual IS300. Now the reason why I did that, I talk more in detail in that video why I did that, but it's basically so that I can use the link that goes back and forth between the body ECU and the factory ECU, whether that be manual or automatic. They always communicate back and forth with each other. I want my AC to work. I want my immobilizer system to work. That's basically why I put the automatic ECU into my manual chassis IS300. So my manual ECU can be sold with the manual transmission that's currently in this and the manual master cylinder and slave cylinder and all of that stuff that I'm not using anymore on this car because I have an upgraded slave cylinder, upgraded master cylinder with a larger diameter because I'm running a T56 transmission. It's down there. And really the only reasoning why I did that in the last video was because the manual ECU costs more than the automatic ECU. So I got a cheap automatic ECU, got it running my car, drove it around, that's all good. One thing that I did in the last video that I actually had to undo was, and I pinned the comment at the top of all the comments after I kind of realized what I had done, but I made a mistake in the last video, and when I opened up the ECU, I cut a bunch of the wires that come from the back of the plug that go onto the circuit board. I cut those if they weren't on the main engine wire diagram here on these 2 pages of the wire diagrams that are there. So I cut those wires if they didn't show up on that wire diagram because I was putting a factory automatic 2002 ECU into a factory manual 2002 chassis. So the wires that I ended up cutting were for it's like the stoplight switch to tell the computer that the stoplight was on, which is not something that would be on the engine control wire diagram. Cruise control, a few of the AC system wires so that the computer could tell the AC system to turn on, turn off, all of that stuff. And I even made a comment in the last video that, well, my AC's not blowing cold. While I was driving the car around, I realized the AC wasn't blowing cold, which is what led me to investigate and dig through the 43 pages of the wire diagram so that I could find what wire colors I actually cut. They didn't affect the drivability of the car. It just kept the AC from turning on, kept the cruise control from working, which cruise control doesn't work anyway if you put an automatic ECU into a manual chassis. And I think that's because there's no speed signal that's going into the automatic ECU. The speed signal is actually going into the manual gauge cluster on the manual chassis IS300s. So I shouldn't have cut those wires in the last video, but it wasn't anything detrimental to the engine functions and the engine controls. I just cut them because they were wires that I noticed that were on my manual harness that were not on the automatic IS300 diagram that I was following. So I just cut those wires just to be safe. But I've soldered them back and my AC works now. Cruise control still doesn't work obviously because it needs that speed signal coming from the speed sensor going into the ECU. The purpose of this video though is to take the Haltech Elite 2500 ECU and change my wire harness that's currently on the IS300 so that I can control the engine with the Haltech Elite 2500. So I'm going to go through all of the rewiring stuff that you have to do to your engine so that it matches with Haltech's wire diagram for their harness, that you can really take and plug and play the harness from the Haltech Elite 2500 and then run the wires to your engine and then plug them all into the sensors like you're supposed to, and then you can just crank it up and run it. But I didn't want to spend the $600, $700, $800 on that harness. I could really convert this harness into the harness that is able to be plugged into the Haltech Elite 2500, and it's only going to cost me about half the price because my 3-part video that I have, part 1 is all the prep work that needs to be done to the engine wire harness before you move the wires into the interior. Part 2 is moving the body harness wires into the interior, and part 3 is moving the engine harness wires into the interior. So you're extending them. That's a 3-part video series that I have. It's down in the description below if you want to check that out. It's very useful. It took a lot of time doing that, and it took even more time for me doing that because I tried to keep all my wire colors the same by using 2 other Toyota harnesses. So that cost the price of 2 different harnesses, which was about $300, and this costed $50. So that's $350 for my own custom wire harness instead of spending $700, $800 on the Haltech harness that plugs into this and then plugs into the engine, and then you can kind of crank it up and go. Mine's a little more involved. That's the purpose of this video though, is customizing the IS300 wire harness so that it can be plugged into the Haltech Elite 2500. I'm going to go through all the things you have to change a little bit later on the wire harness so that it can be run by the Haltech. Anyway, stuff that I needed to buy. So this is the Haltech Elite 2500, but you can't just take the Haltech Elite 2500 and then wire it into your IS300 so that it controls it and runs it. There are certain things that either are overly complicated and are hard to set up on the Haltech, or it's just something that's not supported by the Haltech. One of them being the mass airflow sensor. It's a 5-wire sensor. It has power, ground, and then there's 3 wires that go from the mass airflow to the ECU. Well, it's actually easier to get one of these. This is the Haltech air temp sensor. This is HT010206. This part number will be in the description if you wanted to go down and check that out. But this is just a 2-wire sensor. There's a 2-wire sensor and there's a 3-wire sensor that you can get for air temp. And the reason I'm saying the differences between those two, if you connect this to your Haltech, you have to also enable pullup in the Haltech software. If you get the 3-wire sensor, you don't have to enable pullup. If you're using a different ECU and you're following this video and you don't see something in your software that says enable pullup, read on that and try to make sure that you're wiring it in properly. But what you might have to do is wire in a 1000 ohm resistor to your air temperature sensor circuit, or your coolant temperature sensor, or your oil temperature sensor. Anything that's a temperature sensor that's a 2-wire, you're going to have to wire in a 1K pull-up resistor. Another thing, if you will be opening up your engine, changing your compression ratio, or really putting on a different head gasket and changing your compression ratio, you kind of have to put these in. So these are non-resonant style knock sensors, and you have 2 of them on the IS300. There's one for cylinders 1 to 3, and then there's another one for cylinders 3 to 4. It's the same Haltech part number. It's not on this bag, but really you could just look up Haltech knock sensors. The IS300 uses, from the factory, it uses a resonance style knock sensor, and those are only really good for the compression ratio that you're using those on. So this, I don't remember the exact factory compression ratio, but if I were to change the compression ratio, which I am because I have those pistons and rods back on the wall back there, so those are 9.0 to 1 compression ratio, and I think factory is 10.5 or something like that, 10 or 10.5. So if you change the compression ratio on the engine, you have to change the knock sensors. The resonant style knock sensors, the way that you could tell, other than just visibly looking at it, because the resonant style knock sensor looks like this. It has 1 wire on it. It just looks like a little, it basically just looks like a nut with a little plastic thing coming out of the top of it. But this is a resonant style sensor, and the main indication of that is it has 1 wire. These non-resonant style, they're 2-pin connectors. So they output a more cleaner signal than this, and they're more universal, so they don't have to just be used on 1 compression ratio. So I had to get those 2, but if you don't want to run a knock setup, I don't know why you wouldn't want to, because this ECU supports it. But if you don't want to run a knock setup, you don't care to, or you're just going to try to listen to it and listen for knock, then yeah, don't get the knock sensors. I got those knock sensors because with as much money and time as I'm putting into this engine, I want it to be tuned well and running well. So I got those knock sensors. They're non-resonant style, 2-wire, and they work better with Haltech whenever you change your compression ratio, and they just work better in general. The last thing that I had to get was the wideband controller. This is just a wideband. It's an LS LSU 4.9 sensor, Bosch sensor with Haltech's controller kit. So it's going to be one wideband sensor put into the exhaust whenever I have my exhaust custom made. And if you don't buy a downpipe and you have your exhaust custom made, it is very important that that sensor sits at a 30-degree angle. And that's from the Bosch paperwork. It actually shows a diagram. If you look up the specs on the LSU 4.9 sensor, it tells you to angle that sensor at a 30-degree angle. And that's just to keep moisture buildup from happening and burning out the sensor prematurely. So otherwise, the way, if you angle it too high or you angle it too low or you angle it up, you end up getting moisture buildup on the sensor and it ends up burning it out prematurely. So have the bung welded in at a 30-degree angle. And I've even seen downpipes that were purchased that were, you know, decent downpipe, but they were made, and once you bolt it into the car, that sensor wasn't sitting at the perfect 30-degree angle that it should be sitting at. It's not a huge issue, but if you want your sensor to last as long as it can, put it in at a 30-degree angle. That's the stuff that I had to get. Now on to the engine wire diagram stuff. The differences between my engine and your engine, if you're watching this and you're thinking like, wow, yours looks considerably different than mine. Brief overview of what I've done. I've extended my ECU and the wire harness and everything into the interior, and when I did that, I rerouted all the wires to go back that way because it's cleaner. Once I have my front-facing intake manifold in, I won't have wires that go down here and around and curve back. I don't have anything here where your car, you would have a bunch of stuff bolted in there and then this weird little gray box that's hanging off the side of it. I moved all of mine back here when I was doing my harness stuff because my front-facing intake manifold is actually going to come down and then the tubing is going to route down that way where the ECU box used to be located. And then one of the other things that I changed, I actually I flipped over my wire harness for ignition coils 1, 2, and 3. These are wasted spark setup ignition coils, so one coil fires 2 cylinders. If you didn't know that already, you probably knew that. But the ignition coils, I left coil wiring number 2 the same, but the signal wire for coil number 1 and coil number 3, I flipped those back there somewhere. Like I just cut them and switched them over, and I did that so that I could flip the wire harness over because the wire harness used to come forward and across this way, but I basically just took those 3 ignition coil wires and I switched them around that way so that the wires go back and across to the back of the firewall. These ignition coils will eventually be replaced by R35 ignition coils. So I have a harness and bracket and all that stuff that I've made, and I've got a video on that that's down in the description also, but those don't fit under the factory intake manifold, this whole Y pipe thing that goes into the throttle body. And this is sitting here because I'm actually going to make a little YouTube short at my next video that I post, so subscribe or check that out. I'll probably put the link in the description, but this is a VVTi solenoid connector that's from a 2003 RAV4 2AZ engine, and that engine is also in the early 2000 Camrys. This same connector might be from other Toyotas with VVTi solenoids and VVTi gears. Yeah, but the reason I'm changing that out is because this is actually broken. This little tab is broken, so like whenever you push it on, it wants to pop back. It doesn't want to sit in place. So it doesn't have a good solid connection. And I'm basically just going to repin this connector. In addition to moving all the wires back to the back of the firewall, this switch used to be in the interior. That's why it has this plastic thing around it. I broke some of the wires, so I just really shortened it and put it there. But that has to be there on my car because I'm running an AEM FIC6 piggyback because there's a turbocharger and everything that's bolted onto it that's aftermarket. So this has to turn on the whole throttle body setup because the piggyback can't control the throttle body, so I need that little switch to be flipped. I don't like this setup. I really don't. I don't like having to flip a switch on and off. And that's how the previous owner did it. For right now, that works. My covers are off of the engine because this VVTi gear leaks a ton of oil and I didn't want it pooling up around the belt and degrading the belt whenever the car is sitting. So I took the cover off so that the oil sprays all over the engine bay. And this used to have a cover here, but that was taken off because the blow-off valve and all that stuff. This is all added. This is an aftermarket kit. I don't know the brand of the kit, so don't ask. The previous owner had it installed, so I don't know. I don't know what the brand of this kit is. But small turbo, front mount intercooler. I relocated the ABS. I made a video on that. So I had to relocate the battery to the trunk so that I could relocate the ABS to there from where it used to sit down here. And that's just because I've got a big turbo that'll be going on a precision turbo 6266 ball bearing with different exhaust manifold, all that stuff. So that will be there, but that will be very much in the way and bumping that ABS. So I just moved the ABS over there and made a video on that, which is also down in the description. There's a good chance I'm going to put a chase bays setup in to replace the ABS, because it's not going to work anyway whenever the factory ECU is not controlling the engine anymore. Even though the factory ECU will still be in there, it's not going to be controlling the engine. There's options to remove it, and I'm going to remove it. Another little thing that I did, this is a VSV valve that I'm actually leaving in whenever I have the Haltech all set up and running, but this is the charcoal canister vent. The wires actually trigger this little solenoid to open so that it vents out the fumes from the charcoal canister as they build up. So they vent out through here. Normally they would vent back into the intake, but I moved mine over to this side. It wasn't connected into the intake anyway when the previous owner set all this stuff up. So I moved that over to this side, just also to get it out of the way of the turbo stuff that will be over here, the larger turbo. That little aluminum foil thing is one of my O2 sensors. It has to say connected, but it's not sensing anything. So the ECU sees it, but it's just wrapped up in aluminum foil. It's previous owner said that that has to be done with the AEM piggyback that's on this car. So I don't know, but I really don't like piggyback units, because you have to do things like that and just leave an O2 sensor in the engine bay and then put a little switch on so that your throttle body system works. So that's everything that I could think of that's different on my car compared to your car. Also, if you're wondering what this is, I actually made this wire pin out while I was moving the engine ECU from the engine bay into the interior. So I basically just like mapped out all the wire colors, what they are, what they do, what they go to, so that I can look at it. And it's an easy to follow guide whenever I am wiring in the Haltech. So that's very useful. And it has the 2 columns going up, because one column was automatic, one column was manual. So I've since updated it. That's an older version. It's got a lot of notes on it, but I've updated the one. That's this one, and I'll have this on my website along with this wire diagram. I'll have a link to it on my website in case you want to download it, because this is very useful. This is specifically for the automatics, but it does have some manual references on it. It's mainly an automatic ECU wire diagram. Okay, on to the meat and potatoes. So what is the stuff that you need to change on your factory IS300 wire harness so that you can connect it to the Haltech Elite 2500? So just to make sure I don't miss anything, I'm going to go left to right, top to bottom, and just try to cover everything that's on this that needs to be deleted or rewired. So starting at the top, so the first thing is the injectors. So the injector wiring, the power feed for the injector, it's actually kind of complicated. So what it does is it starts off with a black-red wire, and then it transitions from black-red to black-white. As a black-white wire setup, it controls the power for your igniter, this little noise filter that's back here, that's also for the ignition system. All of the black-white wire, so all the ignition coil system, it feeds off of that black-white section of the wire, and all of that is fed by the AM2 fuse, which is actually under here. So our AM2 fuse is down here, there. So that's the AM2 fuse, and that's the 20 amp. So it should be that yellow one that's right there where my thumb is, kind of beside this circuit opening relay and the horn fuse. That's one of the main ignition fuses. You have AM2 and AM1. So the AM2 circuit starts off as a black wire with a red stripe, and then for some reason it switches from black-red to black-white. When it does that, that's when the ignition coil wiring, so all of these ignition coils, the power wire for them comes off of that black-white circuit. This is also a power wire for this noise filter that's grounded into the intake manifold. That also is black-white, so that's tied in with that same power circuit. And then this black-white wire here for the igniter is how the igniter is powered. That black-white wire, it needs to be run into its own relay and fuse, which I'm going to talk about a little bit later in the video, how to set up the relay block and the fuse block, which is not that complicated, but you do have to buy relays and relay plugs along with a little fuse block, or you can buy Haltech's setup. So after the ignition coils get power, farther down on that black-white wire, as it leaves the ignition coil setup, it goes into the 7.5 amp fuse that I believe is on the interior. The 7.5 amp fuse for the ECU power. So that's the ECU gets its power from that 7.5 amp fuse. And after the wire comes out of that fuse, it turns into a black-orange wire where it goes into the ECU, and that's this here. So that's where it gets its power signal so that it knows the ignition is in the on position. That's what that black-orange wire does on the factory ECU. The wires stay black with a white stripe because that section that turns black-orange that goes into the ECU splits off of the black-white. If you're going to use your factory 3 ignition coils with the igniter going into the Haltech, so here's the full pinout for the igniter wiring on this paper. So igniter wiring, so that's here, right? And you have your ECU connections that I put in this column that's on this second column on the left, and then this is the pinout that's this 10-pin connector that's there, and left to right is bottom to top. So pin 10 is here, pin 8 is open. There's the ground and IGF. So IGF isn't going to be connected into the Haltech ECU. It's only these that are from connectors C13, E27, and E26. That's this gray with a black stripe, black with a red stripe, and black with a yellow stripe, which are, so that's this one, that's pin number 7, this one that's pin number 6, and this one that's pin number 5. So it's those 3 that are beside this open spot. So those 3 are your signal wires for 1, 2, 3 from left to right. So ignition coil 1, ignition coil 2, ignition coil 3, those are the signal wires that are wired into the Haltech. You have to wire those in 1, 2, 3, and then set up as a wasted spark setup with which coil is number 1, which coil is number 2, which coil is number 3. So wire those in the order that they are mounted on the engine. It's not going to be firing order. On older engine managements, you would actually wire it in based off of firing order, but on newer engine managements, you wire it in based off of cylinder order, and you select the firing order in the software. So black-white turns back into black-red for injector power. So all your injectors are powered by the black wire with a red stripe, and the other wire that's on your injector goes straight to the ECU for the negative pulse on-off signal. So they all share a power wire, and that's all bundled together here in the harness that's underneath your intake manifold runner. So to get to that, you actually have to unbolt all of this stuff to expose those wires if you want to tap into them there. But your injector wiring here, so sometime after it splits off from black-white to black-red, you'd pretty much have to sever this main connection here and wire it also into its own separate relay, just like the ignition coils get their own power from their own relay and fuse. These injectors have to get their own power from that other relay and fuse. So I'm going to talk about the relay setup a little bit later. So click on that part of the video if you want to jump to that now, but I am going to talk about it later. But you can check out the progress bar in the bottom of this video to jump to that section of the video. Throttle control motor, I'm not going to use this. I'm not going to wire it in. Like I said earlier, if you want to wire it in, you can look up the wiring on this. It was very complicated to find how to wire in the factory Toyota IS300 throttle motor with the accelerator position sensor or pedal position sensor, whatever you want to call it. And the people that I did read about that wired it into their Haltech, they just had issues with it, with getting it to run. So I don't like this setup personally because it's between 2 eras. It's between the old cable throttle body era and the drive-by-wire era. So it's both. It has a cable coming from the gas pedal, but it has the pedal position sensor that's here. That's not really by the pedal. So it's this weird hybrid setup so that the throttle body can shut off, should you encounter snow or like water or whatever. I don't like it. So this oil camshaft timing valve, I think I read that wrong, but whatever. This yellow with the black stripe and red with the yellow stripe. So that's over here. So red with the yellow stripe is this It's this pin that's on the far side. They're both discolored. They think that this one looks brown on this side, but it's yellow with a black stripe. And this red one with a yellow stripe. So this on, like for Haltech, that one has to be wired to your 12 volt positive. So something that's ignition switched, this has to be wired into, so that when you turn your ignition on, this gets power. And then this goes to one of the regular digital pulsed outputs, the DPOs on the Haltech harness. So that would get wired into one of the DPO outputs. And then back over here, let's see, left to right, top to bottom, I've already talked about all of this stuff. The O2 sensors, all these will be removed and out of the way. All those shield wires are going to be disconnected because I don't want weird signals and weird shield sounds with all of the other sensor ground. This purge valve won't be used. ECU, I'm going to have to maintain the power to the ECU and then run a separate power wire to the Haltech. But this is still going to get switched on like it normally does via this black-red wire that goes into the ECU. So there's a junction connector here. So this junction connector, it's good to know that this black wire, or the brown wire with the yellow stripe that's there, for whatever reason, it changes from regular brown to brown wire with a yellow stripe. And that's just for this O2 sensor. So if you find a brown wire with a yellow stripe that's going into this junction connector, and you're like, what is that? It's still a regular brown wire that goes into like here for the O2 sensor, for this one O2 sensor only. So it starts off as brown and then it goes brown, yellow, something with automatic, and then into a junction connector, and then over here, brown, yellow for manual. I don't know why that's the way that it is. It's really strange. But the main thing to know is this junction connector here is the same as this junction connector here. So all of these brown wires that say BR, those are all brown wires that tie into that junction connector, and they connect the negative side of all of these sensors. And they also connect, so these shield wires that go here, if you follow my finger, all the dotted line wires are the shield wires. So they go all the way over here and they go around your O2 sensors. If you're going to use these O2 sensors, then all of these shield wires that go around there, as well as the camshaft and the crankshaft position sensors and your knock sensors that are there. So all of those shielded wires, they all ground to 2 ground points on the intake manifold, in addition to going into that junction connector that is, it used to be here in the ECU box, but just to show what it looks like, I pulled my wires out so that you can see. That's this connector here. So all of these in the bottom that either have tape around them, the ones with tape around them are the shielded wires, and the ones that are brown go to all of the sensors, and then the brown wire that goes to the ECU and everything. So the way that Toyota set up their ECU, they have all those brown wires grounding to the intake manifold. The way that Haltech wants you to set up their ECU, they don't want any of those brown wires connecting to your intake manifold. So one of the things that's common between every wire harness that's Toyota or Lexus that you look at, every brown wire that you see is going to be sensor ground. And it's different from this white wire with the black stripe that's all bundled together here. That's ground for everything else. So your headlight ground, your fan ground, all of the non-engine component grounds, taillights, everything else that works, that uses a power signal, it's power and ground, is going to be white with a black stripe for the ground. But that's not sensor ground. Sensor ground is brown. And with Haltech, all the sensor grounds go directly to the Haltech Elite or the Haltech ECU, whichever one you're using. One of the ground connections came here to the front of the manifold. I actually moved mine to the back. But if I remember correctly, this one on the front had brown as well as white with a black stripe that was both tying into the intake manifold. If you see something like that, you actually have to snip the brown wires from the intake manifold to cut the brown ground, but you leave the white with the black stripe ground. So leave the white with the black stripes ground if you see that on the connector. And then this one that's down here, if you could see my hand that I just shoved down the side of the intake manifold, those are all ground wires. So you can just unbolt that 10mm bolt. You can cut them if you want, you can move it somewhere else, but don't bolt, just like tape it up or something. Don't bolt it into the intake manifold or the block. Haltech is very specific on that. They said sensor ground, do not bolt that into the engine. that's sensor ground only, and that's a ground that's supplied by the Haltech Elite 2500 to all of the components that are on the engine that need that ground. So one of those being the throttle position sensor there. So that needs the brown ground. Your pedal position sensor there, that needs a brown ground. So all of those are sensor related grounds. Your camshaft and crank position sensor that are down here. So your cam and crank position sensor, this L wire, that's actually the ground wire for both of them. And the cam and the crank position sensors, or the crank angle sensor, whatever you want to call it, those two blue wires, L is blue on this Toyota wire diagram. L usually means blue. So they tie together and they're both shielded. So they're shielded up here. So find where they join together a couple inches away from the IS300 ECU. Separate the two wires so that they can be wired in individually to the Haltech. Well, that would be a lot easier than cutting into your wire harness and everything that you have to do there. These regular signal wires, this green wire and the black wire with the white stripe, yes, it is black with the white stripe, not to be confused with the black wire with the white stripe that went to your ignition coils and your ECU power. For whatever reason, Toyota didn't fully separate and use completely different wire colors for every system. You're going to find stuff like that. You're not going to find brown wires anywhere else. It's always going to be sensor ground. And the same is true for white with the black stripe. But black with the white stripe, you're going to find that other black. You're going to find other red wires. You're going to find other red wires with a yellow stripe. You are going to find issues, but this is not a power wire that comes off of that black wire with the white stripe circuit coming from the ignition switch. This is a completely different black with a white wire, and that's for the crank position sensor. So that crank position sensor wire, that feeds into one of the AVI inputs on the Haltech. So that's just one of the regular inputs for the crank circuit. And this black with the white stripe wire, since it is black with a white stripe, it's different from the other black with the white stripe power. Remember that. That one ties into the Haltech for the crank position sensor positive. And then this is this goes, the camshaft position sensor green wire also goes straight to the Haltech for the camshaft position sensor positive. Mass airflow sensor. So that's this one is going to be completely separated, completely done. I'm not going to have my factory Toyota mass airflow sensor down there because I'm not wiring it into the Haltech. I'm using that 2-wire one that I showed earlier. And it's not going to go pre-turbo like this one is. That's just a bad setup. The setup as it is right now, there is no intake air temperature on any of the charge pipe that goes to the intercooler or from the intercooler. So there's no way that the engine knows what the accurate air temperature is going into this thing, which all it sees is pre-turbo, which can be cool, it can be hot, depending on, this is not the same as this. Once it goes into the turbo, it gets compressed and it gets hot, and then this is your hot pipe that goes into the intercooler, and this is the cold pipe that goes out of the intercooler into the engine. So the temperature can be anything. This can be heat soaked, and this can be hot going into the engine. This can be cold because it's a cold engine. And this could be reading hot because it's a hot day, but after it goes through the turbo, it cools off and everything. So this is just a bad setup. This needs an intake temperature sensor right there. So my mass airflow sensor is going to be gone. I will, however, be reusing these wires. So the 3 wires that are down there, so the blue with the white stripe, the green with a black stripe, and then the blue with the black stripe. So those are the 3, those are on pins 2, 3, and 4. So they're the middle 3 pins on the 5-pin connector. Those 3, I'm actually just going to use one of those wires on the air temperature sensor over here because it's already going to the ECU. Whenever I look at the E5 connector, whichever one of these 3 pins is the easiest one to get to, that's going to be the one that's going to be the new intake air temperature sensor wire. Engine coolant temperature sensor. So this is what I was saying earlier. This is another thing that requires 1K pull-up. If you're using a different engine management, you're trying to set up another engine management, what you need to do is you need to set this up for 1K pull-up. If you don't have an option in your software that's controlling your engine management to select 1K pull-up or whatever else it would be called, I think that's the only thing that it would be called is 1K pull-up, 1K ohm pull-up, or just pull-up. If you don't have an option for that, then you're going to have to solder in a 1000 ohm resistor on the power side. That is going to need to be done. And yeah, that way your engine coolant temperature sensor will operate like it's supposed to. If you have a 3-wire engine coolant temperature sensor, then it's not a big deal. Power steering pressure sensor, that's just wired in like normal if you want to wire that into your Haltech. Also, I should mention your power steering pressure sensor that's over here. That uses 5-volt power. Throttle position sensor, as I said, that's this one here. Your third pin, which should be this one, I think on the bottom. Pin number 3, I can't see, but there, on the connector it's going to say which one is 1 and which one is 4. So pin number 3 is the one that you're not wiring in. And this blue wire with the yellow stripe, that's a 5-volt circuit. So you have to make sure that this doesn't get connected to a 12-volt circuit. This is a 5-volt sensor. So this needs 5-volt power. And it's the same thing for your accessory pedal position sensor. The pinout is different, right? But this blue wire with the yellow stripe, that's on that on this one, it's pin number 4. So pin number 4 on the accelerator position sensor, that one is also your 5-volt. Vapor pressure sensor, if you want to wire that into your Haltech, I think you can. That blue with the white stripe is a signal that goes to your ECU, or would be the Haltech. The blue with the yellow stripe is 5 volts, and then the brown is the ground. Brown is ground. So I like that it rhymes because it's easy to remember if you can't remember. These are from the skid ECU. These are to the skid ECU. It's again not stuff that, those aren't wires that I'll be disconnecting from the automatic ECU. I'm going to leave those connected so that they can talk to the skid control ECU, even if it's not even being used. I'm going to leave those connected. Multiplex communication. These are both orange wires. I know it doesn't say the wire color there, but I think, well, actually, I think one is orange and one was blue on the wire loom. And then coming over here, these are transponder key amplifier. These are more wires that I'm going to leave connected to my engine control module, so I'm not separating those. They're going to stay connected to it. Knock sensors 1 and 2. If you're using the resonant style knock sensor, it's good the way that Toyota used it and how they're using it. But once you start modifying your engine, or if you change out your ignition coils and you're getting a lot of extra noise from larger injectors, bigger ignition coils, you're probably going to get that feedback fed into your resonant style knock sensor, and it's going to be picking up extra noise. So it's better just to go with the non-resonant style 2-wire. You're going to have to run 2 extra wires from this knock sensor 1 and knock sensor 2 shielded, so shield those wires. But yeah, so run those 2 extra wires. Your cam and crank sensors, I talked about that. This brown is the one that I mentioned earlier that needs to be severed. Your oil temperature, oil level, so you can wire that into your factory Haltech, but how it's going to operate is your oil level sensor. If it gets too low, it's going to trigger this. It's basically just like a little flapper switch thing. So if your oil level gets too low, it's going to trigger this. It's going to connect to the ground, and it's going to tell the ECU that your oil level is too low. Or if your oil temperature gets too high, it's going to tell your ECU that your oil temperature is too high. So that's also something that you can wire in, but you would wire it in as you would wire in any other ground switch that you're wiring in to a Haltech. So this is not going to be a positive feed, it's going to be a negative switch input. Your engine oil pressure switch, so this is just, it's basically just an on-off switch. If your oil pressure, if it drops too low, then that engine oil pressure light comes on. So that you would wire in also as just a ground switch, because that's how it operates. Ground switch, if it switches, then yeah, your oil pressure is too low. And this one is from AC compressor relay. That one I'm going to leave connected to my engine control module, along with this that's from the park neutral switch or the clutch start switch. So that's a ground switch that comes from either one of those circuits, and it goes into the engine control module. That one I'm leaving connected also. That's pretty much everything that you have to change regarding the IS300 wire loom. And again, recapping the main, I think it was 5 changes that you have to make to the wire loom. Just recapping everything. You have to sever the engine ground, brown wire. Brown is ground. So all these brown wires end up, they're ground that's supplied by the factory ECU, but they all ground to the intake manifold. Haltech doesn't want you to do that, so you have to sever the ground wires. The 2 ground points are here and down there. So these would have white with a black stripe also. From what I remember, because I moved mine back there, but some of these would be white with a black stripe and some of these would be brown, both going into the same 10 millimeter ground bolt thing. Cut the two browns and solder them together. Leave the ones that are white with a black stripe. That's change number one. Change number two, injector power. Injector power is coming off of the black wire with the red stripe, so you're going to have to cut into your harness or I guess wire in each one of the injectors individually, but you're going to have to cut into the harness and find that black wire with the red stripe and then feed it into Haltech's separate relay that's for the injectors. The injectors get their own power from their own separate relay. Same thing is done with the ignition coils and the igniter. That's this white wire with the black stripe, feeds off of the same circuit that the injector power is on. It's on the AM2 circuit. So the AM2 fuse that's under that little box over there. Black wire with a white stripe is power that goes to each one of these ignition coils, that igniter, and that noise filter that's back there that I moved that used to be up here. So all of those things need black wire with a white stripe power going to also its own separate relay and fuse that is something I'm going to talk about in a little bit. Change number 4, because that's the coils were change number 3. Change number 4 is as a charge temp air intake sensor to get rid of your factory Toyota air intake sensor, which would be going into your air box or your main airflow. And this one, it's been moved here pre-turbo, but it actually needs to be post-turbo on your charge pipe coming out of the intercooler going into your intake manifold. Hopefully not near something like this that's going to get heat soaked. You could probably put it up here where it's farther away from engine heat, but you need it as close to the engine as possible so that it knows the air temperature going into the engine that's accurate, so that the ECU can adjust accordingly and you don't have to worry about knock. Change number 5, what I'm doing is I'm actually completely severing these wires for the throttle control motor and the accelerator position sensor, and that's not going to be used at all. Change number 6, this wire is going to be completely separated from pin number 3. That's not going to be wired into the Haltech. Change number 7, this red wire with a yellow stripe that's on the VVTi solenoid, that needs to be wired into 12 volt ignition positive. And change number 8, I guess, the blue wire that is the ground for both the cam and the crank position sensor, that blue wire, so find where they join together a couple inches away from the IS300 ECU, separate the two wires so that they can be wired in individually to the Haltech. This brown circuit that, again, is not grounded to your intake manifold, it's grounded directly to your Haltech and not to the engine. Those are all the changes that you need to make. The main thing that you need to know with powering some of these, this blue wire with a yellow stripe is 5 volts positive that's supplied only by the Haltech ECU, or in this case the IS300 ECU, but it will be the Haltech ECU. So blue wire with a yellow stripe, that's what that does. And those are all the changes that you need to make in a nutshell, recapping everything to this harness. So there's a lot of things that won't be connected to the Haltech that are currently connected to the ECU, but that's okay. It can still control your engine. My end goal is to still have the IS300 factory ECU connected to the skid ECU and the body ECU, so that all that stuff, so that it thinks it all still works, but it really doesn't work. It's just there so that my AC works and the other stuff. So that's the absolute basics. I hope I covered everything. So now we're actually going to go inside. I'm going to talk about the factory ECU, how I'm kind of rewiring that to and rewiring all the pins and everything to go into my Haltech connector, and also talk about my fuse and relay setup, the way that Haltech wants the fuse and relay setup for this engine as it's controlled by the Haltech Elite 2500. This is my little diagram that I drew out, and I would highly suggest you drawing out something like this just so that you make a note of everything that you have to do to change your factory harness, and that way you can mark off stuff, put it on paper. I put it on a whiteboard because it's easy to make notes and correct things on a whiteboard. But laid out visually so that you could understand what I was saying earlier. This is the ignition circuit as it goes from the 20 amp AM2 fuse into your ignition switch out of the, I didn't write it, but it comes out of IG2, and then it turns to your black wire with the red stripe, and then somewhere along the way it switches from black with red to black with a white stripe so that your ignition coils can get power along with your igniter and your noise filter. And also somewhere down this line it switches off to your 7.5 ignition fuse, which turns into a black orange wire, which goes into and tells your factory ECU that the ignition switch is now in the on position. Over here it switches back to black with a red stripe so that all of your 6 injectors can get power, and each of the 6 injectors get signals from the ECU. That's what that little green wire is. I don't know why I drew that. That's kind of a given. Haltech actually has this part of the wire diagram, which is this. They have it broken out into more detail in other wire diagrams if you want to find those wire diagrams. They have it on their website. But if you want to build this and not buy this little box, I'm actually building it just because I don't want to pay for the box. But it's all wiring. It's not like it's bad making it yourself. It's just usually not as pretty if you make it yourself. I don't care. It's got to be hidden. So these left to right, if I flip it over, are ordered left to right, just like this and just like that. So the wiring on this, pin number 85, if I flip it up here, that's actually going to be this right pin on there, and there. So that's pin number 85. All of those get powered directly from this far left fuse, which is that fuse there. That's that number 1 fuse, the ECU fuse. So all of these relays get powered by that. And this goes straight to the battery. According to this, it wires straight to the battery. I want to double check to make sure that this isn't an ignition switched positive, but it looks like just battery positive. You can use a 75 amp circuit breaker if you want, according to this, but it looks like you just wire straight to positive. Not ignition switched, straight to positive. The pin 86 on this left side of the connector, so that is the relay ground. And inside the relay, you have 2 completely separate halves of the relay. You have the electromagnetic circuit that just opens a little gate, or closes a gate technically, so that it allows power to flow through. That side of the relay is completely separate. It's only connected by a thing that's moved via an electromagnet. The wires themselves for 85, 86 don't touch any other wires inside the relay. So 86 is the digital pulsed output ground. So this goes ECU, injection, and ignition. Those all tie into this DPO 6. This is what they have labeled as the black wire with the red stripe. DPO 5 is the fuel pump trigger. That's a separate trigger, and that's probably so that it can prime it as it wants to and control the fuel pump relay independently of these other 3 that need to stay on. The input to each one of these relays, as I've drawn out here, so ECU would be this far left fuse, injection would be this second one from the left, and then ignition, and then fuel. So each of those go into pin 30 on each one of those 3 relays. And then coming out of the relay on pin 87, you have the power that's going to the ECU, but this ECU power also splits off and goes to all of your other sensors and relays and solenoids and things like that that would be not 5 volt, because your 5 volt, actually says 5 volt sensor supply is here, that's pin number 9, and that would go to all the 5 volt sensors and everything. But that's power that's supplied by the ECU only. This output, it says 13.8 volt output, but it's technically the 12 volt output that comes out of the relays off of the battery. Just if the alternator is on, then it's going to be around 13.8 volts. But that voltage output goes from the ECU relay to each one of these output sensors, relays, solenoids, everything else that you need to be triggered on with your ignition switch turning. The red with the blue stripe comes from the injection, and that comes off of pin 87 of that relay, and it goes to all of your 6 injectors power. So it splits off and it goes to each one of the 6 injectors. Red with the yellow stripe, it's the same thing, but it goes to the ignition coils, the igniter, and your noise filter. I'm pretty sure the Haltech doesn't need the noise filter set up, so you can just pretty much delete that. I don't think the igniter uses it. I think it's more for the IS300 ECU. So you can probably delete that and not have any negative side effects, or leave it connected and not have any negative side effects. Your positive side of the fuel pump, so that's positive wire that's coming out of pin 87, fuel pump relay, going to your fuel pump. So if you're going to upgrade your fuel pump wiring, then obviously you would upgrade the gauge depending on how much amperage your fuel pumps draw. So if you're running 1 fuel pump, 2 fuel pumps, 3 fuel pump, that's going to have to be the right gauge wire size for all 3 of those. And the ground wire size is going to need to be updated also. So that's the basics on how you would wire in this relay setup. I just breezed through it because they actually have a full wire diagram that's more detail in this that shows how all of that is broken down. And all those links I'll have in the description of this video. Everything else that came, like this came with the Haltech Elite. And this is a front and a back, and it just shows how to wire everything in, which things will be wired into your outputs for the injectors or the ignition and what you can use them for. All that is kind of laid out on here, so you know. You select in the software what you have selected for each thing. Like whenever you select those options that you have installed on your vehicle, you can drill down into that section in the software and then select what wire you have controlling, the throttle position sensor, your map sensor if you're not using the built-in Haltech map sensor. You just have to definitely make notes on which input if you have a connector like I have, that's the connector that fits onto the Haltech that you have to wire in yourself. Definitely make note of which pin, because your wire colors are obviously going to be different because you're using your own wire colors. So there's that. Also, if you're doing soldering, since I have this here and it reminded me, I like to use a full face mask because I don't even like the solder fumes getting in my eyes. They're definitely not good to breathe in. So you need something that's good. This is just a 3M full face mask. Don't go cheap on these. Get a good one, because you don't want to breathe this stuff in, especially if you're going to be doing a lot of soldering. You don't want to breathe in solder fumes. People get like brain damage if they're constantly soldering. Brain damage is a thing that's known. And then coming over here to the automatic ECU, my original plan of running all the wires out of this, I'm actually not going to do. I'm just going to cut the wires before they even go into this ECU. The only wires that will be remaining going into this ECU and coming out of the ECU will be the ones that go to the gauges, ones that go to the skid control ECU, ones that go to the AC and immobilizer, all that stuff. So my immobilizer, that when I rekeyed that in the last video, I rekeyed the automatic ECU to accept my keys that were programmed to the manual one, which I had to make a little connector, and I talked about that. So check out that video if you kind of wanted to do the same thing. It's not very difficult. It's more difficult making the little adapter that clamps onto the board so that you can reprogram the keys for this one to accept the keys from your other ECU. But I'm not going to video all of the soldering and cutting and wires and everything, because I talked about everything. So if you were making notes, then that's awesome. Good for you. I'm not going to walk you through everything that you need to do. Like, this wire goes to this injector, this wire goes to this plug on the ECU so that it goes to this injector and whatever. That's not something that I'm gonna walk you through. This is the automatic ECU that was controlling the IS300, and it does a good job. But the wires will be severed, cut from the beginning before they even go into this ECU, so that it won't even know that the engine's running. Also, this won't be controlling the check engine light anymore. This will strictly be controlling the skid ECU, the AC, all of that stuff. And then I can sell my manual ECU, and yeah, it'll all be good. In the next part of the video, I will be showing this with all the wires cut and soldered into the Haltech and everything that needed to be done to do that. So it's gonna be kind of a long video, but very informative. All right, if I pan over here, you'll see there's no intake manifold and there are wires everywhere. So I'm just gonna walk through and talk about everything that I did before, because the Haltech's still not connected, but I have all the wires set up and it's pretty much ready once my car battery's finished charging for me to plug it in and then go through the configuration and everything. This is where I tapped into the power. This is always hot, so I used this little pin here. Then I couldn't get this out, even though there's 2 snaps there, and then these 2 snaps. Once that's taken off, I couldn't get this out because the wires were so tight. So I just ended up drilling a hole in the very bottom of this from the bottom and not damaging any wires carefully, so that I could connect this 40 amp fuse. And that's where the the main power for the engine management, and the new ignition coil power and fuel pump. All that stuff will be powered off of that. I could upgrade the fuse later if I want. I just have to pop that one out and put another one in once I figure out the correct amperage on everything. And then the wire just runs along here, the back of the firewall for now, until I put it in another place. But anyway, left to right, everything that I've changed. This is the new intake air temperature sensor that I pointed out that was in the bag earlier. And I had to put these 2 pins in. It was pretty easy to do, just crimp them. I put a little dot of solder on each one of the wires just so that it's a solid connection. I've been doing that to every one of the pins that I've been doing on the Haltech connector. This is the old mass airflow sensor, so this is the new one, and I just have it going into this. This is not a good idea. I put that there because it's quick and it's easy, and it's not going to leak very much air because it's a pretty tight fit. So don't comment on this. I know it's a bad idea. This engine, the clutch slips horribly, so it barely builds 1 psi of boost anyway. The correct way to do this would be to weld on a bung and like onto your charge pipe, so that you can screw this in. It's 1/8 MPT, so you could screw it in to the bung, and then you'd have it mounted like probably right here. There's 2 other wires that go to the ECU area, and there's one power and there's one ground. So if I want to connect something else, I will probably end up using these other 2 wires as digital pulse outputs for my 2 MAC valves, because I'll be running a dual MAC valve setup on my, I think it's a turbo spark wastegate that I have. Moving over a little bit more, this is the old throttle body wires. These have been severed from the ECU, so this is no longer getting any kind of power from the ECU. And then this is the pedal position sensor wire. So it's still connected to the 5-volt power supply, which is here. This little bundle that was sitting under the intake manifold, and that the bundle of harness wires. So that's still connected to this, but it's not going to be plugged into anything. You can see the cam position sensor wire now. So this is the cam position sensor. That's the location of it that I couldn't point to earlier. So that's down there. And the 2 wires coming out of that, so the blue wire that comes off of the cam crank sensor and the blue wire that comes off the cam sensor, they join together a couple inches away from where the wire goes into the ECU pin. So what I did was I actually cut those 2 wires before they joined together to go into the IS300 ECU, and I extended them so that they each go into their own separate pins on the Haltech connector. That way both the cam and the crank both have their own negative reference signal for the Haltech to determine a good proper ground, and see a good positive signal too, because it has a good ground reference signal. So both of those blue wires were cut and extended, and they now go into the Haltech as 2 separate wires, not joined together. This is one of the ground bundle wires, and this is the other ground bundle wire. This bundle used to connect to this and one of these brown wires, and this was the wire that used to be on the front of the intake manifold. So one of these brown wires went to one bundle, and then the other brown wire went to the junction connector that's on the interior. So what I did is I actually looped them together. That's this. These 2 used to go straight into here. So now the junction connector that I'm going to show in a little bit, that I'm reusing to join all the brown ground wires together, that is connected directly to the brown bundle. That's not the brown bundle. The brown bundle, wherever it was that I just grabbed it. I don't know. It's the brown bundle. Yeah, I don't know where it went. There's another bundle here. This is the power distribution that used to go to O2 sensors and everything. So I pulled all my O2 sensors out. These are the power wires. I'll be reusing those in the future. I gotta safe those off, the tips, because I don't want the tips to touch the body anywhere. This is the VVTi solenoid. So again, I'm gonna have a YouTube short coming up pretty soon, just talking about replacing this connector, because this the snap thing's broken off of it, so it kind of just hangs out wherever it wants to. It doesn't fully connect. But in hindsight, and actually what I think I'm going to do to reverse what I did here, I wired one of the O2 sensor power wires directly into this, which is not a bad idea. It'll work perfectly fine like that. But there's this wire that's hanging out there that I don't have anything to do with, and I'd have to snake it back out of the harness and everything. So I'm actually going to pull this back out whenever I repin this. I'm going to pull this back out, and then this wire is going to get power on the other end where I severed it from the ECU. So it'll still be getting power from this whole black wire with the red stripe bundle that goes like over here wherever I picked it up earlier. So that black wire with the red stripe bundle, it'll still be sending power through this wire. It'll just be doing it from the other end. And then my ground point that was down here, I've unbolted that and I've taped it up so it can't touch anything. I tried to pull it up through the harness and everything where it's where it is, and a little bit of trouble with that because it's so wrapped in to the harness. I just kind of just said forget it, and I taped it all up. So I'll just leave it there, and then whenever I pull the engine out and I have the harness more exposed and I can customize it the way that I want and tape it up the way that I want, then I'm going to take those brown wires and probably do something with them then. And then the igniter. So these yellow dust cap wires are all the ones that go to the ECU, and these are 1, 2, and 3. So those are all connected to the Haltech now. They're not connected to the IS300 ECU anymore. And this IGF wire, I've severed it from the IS300 factory ECU. Whenever I swap the head out and I customize it the way that I want this to be, it's not going to have the factory ignition setup anyway, so this igniter is going to go, and this igniter along with the 3 coils and all that stuff are actually going to be replaced fully with the R35 individual coil setup. And then I also mentioned the power for the injectors. That's been fed into the new Haltech relay, and then the power for the ignition coils, that's all fed into the Haltech relay. And really quickly, I do want to talk about this because it's pretty important. This is labeled a fuel pump relay, but technically this is not the fuel pump relay. All this relay does is whenever it's triggered on, inside the relay, it shuts off the connection so that the power is forced to go through your fuel pump resistor that sits here. So it's easier for me to tune. I just bypass that completely. So this relay, it's not even connected at all right now. All it does while it's plugged in is it just acts as a jumper. If you do take this out, you have to jump pins 3 and 4. It's really difficult to get out. I actually broke the top of it trying to get it off. It's a relay that's normally in the closed state, so it's not a normally open relay as most of them are. The fuel pump relay is actually this relay here that is called circuit opening relay. So that circuit opening relay, that directly controls fuel pump. Whenever that gets a signal, it turns the fuel pump on. Whenever this one gets a signal, it turns off that relay so that the fuel pump power is forced to go through this resistor for the fuel pump so that it's quieter while you're idling or whatever. Another quick note, I'm not going to be running an idle air control valve on this setup because really the only reason I'm doing all of this wiring, well, partly is for making the YouTube video for like how you can do this all yourself. The only reason I'm going to all this trouble to do this is so that I know that I have a good working setup on the Haltech controlling this engine, and I know that my wiring and everything is good. So that way when the new engine and everything is built and in, then my wiring I know at least is good, and then it's just setting up the new configuration stuff in the Haltech. So this is just, I'm just trying to get this to run. I don't need an idle air control valve. There's tons of guys that drag race their cars that don't even like dealing with idle air control valves just for the possible point of failure. So I'm not running the idle air control valve because this is not going to be a daily driver as it is like this. That's everything that I could think of that I needed to change regarding this. This is new. This is since the Haltech Elite has a built-in map sensor, the other end of this hose is going to go straight onto the Haltech whenever it's mounted. So this is an 8-foot hose so that it can reach the intake manifold, and also so I can I have a few feet that's going to be in the interior so that I can move it around to wherever I want to. So going over here. Now, first of all, I know this is a huge mess, but try not to focus on the mess and just try to focus on just the parts that I'm talking about. All right, coming in here. So if you see these both black wires with a white stripe. So one of them went into this connector. If you look at it on this side, this small gray connector that goes into the big gray connector, the small gray connector side, this is the side that used to go into the engine bay, like say for this wire, the black wire with the red stripe. This wire used to go into the engine bay to power the injectors, and the black wire with the white stripe used to go into the engine bay to power the ignition coils. These two, they're both black with a white stripe where they go into this connector, regardless of whether they go into the injectors or the ignition coils. Both of them are black with a white stripe, and both of them actually come from like back there behind all the wires, which you can't really see it, but it's on the very, very bottom kick panel. These go straight into that little wire bundle, like where I'm shining the flashlight on that white thing. but on the back near the bottom corner of the firewall. So those two wires, they actually go in over there. I've got to safe those off because whenever I turn the key, those are going to be hot. And they're heavy gauge wires, so they're going to snap the AM2 fuse, because those go directly to the AM2 fuse. So if they touch ground, they're blowing a fuse. But simplifying all of this, even though I know it's a big mess, I know there's people that are going to look at this and think like, wow, this is overwhelming. I don't think I can do this. You can do this if you take one wire at a time, do one wire at a time, and just go down the list. You can do this. This is really not as bad as it looks, because it looks bad. It really does. That alone just looks like this is spaghetti. This is straight spaghetti. The basics of everything that I did, I cut the wires from the IS300 ECU for the solenoids, the injectors, the coils, the sensors, and I moved them over to Haltech. So these two Haltech connectors. So those were all soldered in individually. Brown wires were all connected, and they go into this junction connector. Power wires were all connected here, and this is main power from the battery. Goes into the fuses, which goes into the relays. Relays are triggered on by the Haltech, and the relays also trigger on the IS300 ECU, because the IS300 ECU used to be triggered on by the ignition switch, which now the Haltech is triggered on by the ignition switch. Then the Haltech powers up these relays, and then the relays power up the IS300 ECU. And then everything else is just connecting power and ground. All in all, this really wasn't that bad. It just looks horrible. Other little things to note, which aren't too much of a concern really, but even though, so like number one, even though your clutch start switch goes into the ECU, it doesn't keep the ECU from starting the car. So you can cut the clutch start switch on this wire loom, like as it comes out of the IS300 ECU, you can cut that, because I think it's mainly for cruise control. The car still starts even with that wire completely disconnected. So there's that. And number two, your radiator fans. So your radiator fans, they have multiple controls. So the AC can trigger your radiator fans, your IS300 ECU can trigger the radiator fans, or an actual temperature switch that's a physical switch that's on the engine that can trigger your radiator fans. So you don't technically need to wire in this into a DPO output on the Haltech so that the Haltech can switch on the radiator fans, but it doesn't hurt. I'm assuming that in order for your AC to work and everything like it's supposed to be stayed in, that wire for the radiator fans is supposed to be connected into the IS300 ECU. That way, when you turn the AC on, the radiator fans still come on. So I am leaving the wire in the IS300 ECU, but I'm also wiring in a second wire so that my Haltech can control the radiator fans, the IS300 ECU can control the radiator fans, or the other systems that turn them on can still control the radiator fans. You can kind of do what you want there. There's a few fail-safes on the engine so that your radiator fans do still work and come on. So at this point, right now what I'm going to do is just start mounting the ground where I'm going to mount it, put the wire on the battery. This is the ground wire that goes to the battery, and then connect my relays, start putting things where I want them to go, connect this into the Haltech, and then boot up the laptop and configure a base map. All right, I'm online with the Haltech. It takes about a minute for it to boot up right now because it's running the ESP software. And if you look over here, so the NSP is something I'll do the little update to a little bit later. Not in this video, but you can update ECU for use with NSP software. I haven't tried out NSP software yet, and this is a good chance for me to try it out. It's their new Nexus level platform. First, I'm going to load base map. So Lexus, IS300, and I'm 2002 to 2005 because mine's 2002. I'm going to open that. All right, ECU is connected. So I'm going to go down here to, so open ignition system, open injector system, and where's the cam trigger stuff? I've not enabled that. That's not set up yet. That's not selected yet. So I'm going to go up here. trigger, so okay, that's why. So it's a generic standard full cycle trigger. So I just loaded the base map. I thought it would be, so I guess loading the base map isn't set up for Toyota. 2JZ, where are you? So yeah, so you have two options. I have the the GE right now. I'm about to put a GTE head on it, but either way, they both use the same cam and crank trigger. So I'm gonna set that up. Trigger on crank, 36 teeth, 2 teeth missing gap. Right, that's true. So TDC offset angle, that's not right. What is Haltech? Haltech has this nice page here that says all their engine specs. So and this is specifically for the 1JZ, 2JZ engine. So I'm going to go down, has your basic information here, but actually I'm going to change that first. Main tab. So it looks good, 153624, that's the firing order, so that's correct. There's no sense to check odd fire. VIN, I'm not going to put that in, I'm just going to name it Purple Turtle, because the car is slow. Right now it's slow, and it's purple. So, max cranking RS, that's fine. 5-speed manual, so that's good. It's a trigger, so back to this, the offset angle is like 5 something. Where is that? So that stuff, here we go. So set this up, so set up trigger really quickly, and this is TDC offset angle 5 degrees. Oh, that's not, that is non-VVTi. There we go, 515 degrees. 515 degrees, TDC offset angle enable 1, enable, the offset angle that. 1, enable, custom falling edge. So right now it's set to Hall effect. But watch this. So the trigger, there's the trigger. So I go over here. I'm going to open that menu back in a second. So you see it says TDC offset angle. It just says offset angle table. But if you go here, you have trigger activation, trigger arming, home activation, home arming. Like that stuff's not set up in trigger properly. Well, okay. Well, it's not set up here because you have to set this up. So once you select, if you have it set to reluctor, then you have the home stuff appear. So like home arming, home voltage, TDC offset angle. So like it still doesn't have the home activation and trigger activation, right? Because those are here. But I have to select custom as it shows. If you follow all of this and you put all of these in exactly as they are. So I'm going to set up custom, and these are disabled, falling edge, filter level, I don't know what it was. That's 0. Disable, 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 AC, enable 20, disable, 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 AC, custom falling edge 0, disable, 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 disable. I don't know why it's not showing the other options underneath it, but enable and 20% edge rejection ratio. But over here, home signal, custom falling edge 0, disable, 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 custom falling edge 0, disabled, DC, this was 500, always, AC, 500 always. And that's set up, so now I can apply. And I just double check and make sure, because I double check everything. That's why it takes me so long to do stuff. So now these options are enabled because I have it on the custom setup. So trigger activation voltage, I'm going to plug that in here. Make sure this was for, yeah, variable valve timing. Trigger activation voltage, so 200, 500,000, 2,000, 4,000. 200, 500,000, okay, so those numbers on the top are right. So it's 0.25, 0.25 all across. So negative 0.25. I should have done this. No. Now there's trigger arming voltage. There's 204 to 25,000, 2468. 25000 2 4 6 8. I have to add a 6 and an 8. You just start typing. You just select the cell and start typing, and then it puts it in. I always like that. So now it's 0.15, 0.3, 1, 2, 3. Triggers are set up. That's the trigger configuration and the trigger activation, home activation. Like I said, trigger is for crank, home is for cam, and each of those two wires are both wired directly into the Haltech. The negatives were joined together on the factory configuration of the wire harness, the blue wire, the L wire on the diagram. So I cut that one where it joined together, and then I split them off. This is all the wiring information. This I want to go over really quickly because it says if you're using Toyota OEM wiring, pin 2 should go to signal ground. I didn't do this. I put pin 2 directly to the negative. I think it was like pin 5 or 6 on the B connector. So that's not the way that I wired it. We'll find out if there's an issue with that, but pin 1 is going to, I think it's pin 1 on the B connector, and then pin 2 is going to pin 5. And then the cam position sensor, I believe it's the same, but it was pin B2 and then pin B6 for the Haltech, for the cam sensor's ground reference signal. Ignition dwell time. So I want to look at that. So ignition dwell, where did we see the ignition dwell time? Is at the bottom. Dwell time, coil and plug models. So 6, 8, 10, 12, 14, 16. 6, 8, 10, 12, 14, 16. The voltages are right. 2.6, 2.4, 3, 2, 2, 1. So you double check that. Constant charge, falling edge. Wasted spark setup because there's one coil for 2 cylinders. Okay, so it set up some basic stuff. Main setup. That's actually not right, it's 2997. Move over to functions. So cam control switch. I'm going to consult my little paper that I wrote out everything on and all my inputs. So this is the cam gear, the solenoid for the cam control, and you connect it to A34 stepper, so that's correct actually. Check engine light is A23, DPO3, A23, that's correct. Coolant temperature sensor, this is the factory coolant temperature sensor, so if you don't have the factory coolant temperature sensor, you can change the values here. Now when I first plugged everything in, the wideband O2 sensor, so it wasn't actually selected, so I selected it, and then after I did, the little warning thing popped up because this was unchecked. So if you go back here, then it's like, oh hey, there's, selected input doesn't exist. Well, it doesn't see it because the wideband controller box isn't seen. Vehicle speed sensor, since I have the manual ECU, the manual model, the manual speed sensor wire goes straight to the gauge, where the automatic goes to the ECU. Right now I'm not going to have a speed sensor that the Haltech is picking up a signal from. It's just going to be shown on my gauge. So eventually I'll change that. I'll probably pull it from one of the wheel speed sensors for the ABS, because I'm not going to have the ABS for much longer anyway. So manifold pressure input, I'm using the one on the onboard pressure sensor, but if you switch it, you can use, whatever. I'm using the one that's built into the Haltech. the radiator fan. So the factory IS300, I have the ECU still controlling the radiator fan right now. And I'm doing that because of the AC control. So I'm going to experiment a little bit later, just see what happens whenever I have the AC running and I clip that wire if the fan's shut off. Because I don't know if the fans are controlled by the AC system or if they're controlled by the ECU whenever the AC is on. I'll mess around with that. This is where you would put your dead times, whatever injectors that you're running. So I actually do not know the injector dead times for the injectors that are in this. It's running the 1MZ. They're like a dark blue injector. And it says Denso 3130 on the side, I think. If you do know your injector dead times, you would put those in here. That's basically how long it takes for the injector to come on whenever it gets a signal to fire, which is pretty necessary. So I might have a little bit of an issue. I don't know how far off these dead times are from what the other ones are, but I do know that they are 250cc injectors. The injector size is down here. Flow. 250 cc's. So it's kind of a low injector flow rate. Take air temperature sensor. So this paper says, it's kind of funny, like these numbers are the exact same numbers that show in my little paper that came with the Haltech air temperature sensor, because the air temperature sensor that I'm running is the Haltech, not the IS300 air temperature sensor anymore. So that mass airflow, the factory IS300 one is done, is gone, and I'm just running this one. Throttle position sensor saying 100% if you notice, and that's just because it's not configured yet. So I'm going to go to calibration, and then I'm going to start the calibration. So before I start the calibration, I want to say that my calibration is going to be different than yours if you're running the drive-by-wire setup or if you're running a completely different throttle body. So what I'm going to have to do is I actually, because of the way Toyota designed this throttle body, with it being part drive-by-wire and part drive-by cable, the cable only opens at maybe 25-30% of the way or so. And if you look down here, this says 100 and 0. So if I configure this by pressing the pedal all the way down, the throttle body is only going to open to about 25-30% of the way with the cable. The motor has to assist it the rest of the way with opening fully. So the throttle position sensor is not going to get a full reading. So what I actually have to do is I took my intake pipe off the front of the throttle body so that I could put my hand in there and then move the throttle plate all the way up to 100% whenever I get to step 2 here, and that calls for, you know, pressing the thing all the way down. So I'm going to click start. So ensure the accelerator pedal is not depressed and click the calibrate button. Press accelerator pedal fully, which what I'm going to do is open the throttle and stick my hand inside. Oh, this is awkward. My hand barely fits. Okay, it's open all the way. Calibrate. And finished. So that's that. My throttle body should show. So to apply. Okay, so as you can see, I've got my TPS set to 0 now. So I know you can't see, but I'm turning the throttle now by hand on the engine. And then right now I'm starting to feel resistance. So it moves about 45 degrees on a 360 degree thing. So it moves about 45 degrees, and then when it moves another 45 degrees, that's when it stops. And it stops at this 43% open. So this 45 degree to 90 degree spot on the throttle body is 0% TPS to 43.8 TPS. Yeah, so that should be reading properly now, and I should be able to start it and drive it around if I wanted to, but it's not running with the throttle body motor, and it opens 43% TPS. In my knock detection, I'm actually going to disable right now. Since I have the resonance sensors in, I'm going to disable it until I put in the non-resonant 2-wire sensors. So that's disabled. Okay, my tachometer, haven't set that up yet. So tachometer, tacho, and I put that on DPO2, so edit connection, DPO2. My evap sensor I actually connected I know I have to edit the connection, so I'll add the connection. I put that on B17, so B17 is here. My oil pressure sensor, I'm actually going to, it's disabled right now. Let me enable it so I can add the data into it. I don't know what connection I'm going to put it on yet, but calibration, so I'm going to set this up. I'm just reading the values off the side of the sensor. So the output is 0.5 to 4.5, 0.5 to 4.5, so that's correct. And then the range is 0 to 150. Oh, that's exactly what is in. So it's by default is already set up to my oil pressure thing that I have right there. So that's, I'll just leave this disabled for now, and it'll stay in the list. If you check it down here, then it selects and it throws it up here. But if you uncheck it, then yeah, like let's say boost control. Whenever I install my Mac valves, they're not on it right now, so I can add it to the top and then disable it until. I'm going to put a fuel pressure sensor on. So that will be later. So I'm going to add that, disconnect. Drive-by-wire. So eventually I am going to, I know, oh, what's it? Do you show me this message again? I'm actually going to set this up according to Haltech's instructions. They have a diagram for setting up their drive-by-wire specifically. Edit connection, so this is going to be AVI2. I don't know why these are showing voltage inputs. They're actually not even wired. This is some kind of bleed over from the actual harness. So let me uncheck that now that that's set up. So the calibration, you go through the calibration the same way that I did the calibration earlier with the throttle position sensor. So I'm just going to disconnect this, disable it, apply, make sure my TPS didn't get all funky. Calibrations, that's all still the same. All right, go over to ignition base map. 10, 50, so that's a good start. It's not too crazy. And fuel. So let me see if I can start this as it is with this map. And it starts and it runs on the Haltech. First try, actually. That is not bad. What is my air fuel? Where is my air fuel? Lambda, there we go. So 14 point, wow, okay. At idle, it's right at 14.7. It does need to be tuned and set up, but it runs, it starts up. That's exciting. So I'm running fully on the Haltech. The other stuff is not set up. So, and it is a base map, but I am pretty surprised that it started up first try without me having to adjust the fuel at all. This is a turbocharged vehicle, and this map here, both ignition and fuel are both set up right now for the non-turbo application. So I'm going to have to adjust the ignition map and adjust the fuel map. But as this is, if you followed everything that I just did, you can drive it to your tuner and then he can configure everything else. Download this software for free, install the base map for free, like run it on your computer, mess around with the settings, try to get familiar with it if this is something that you want to put on your car before you even attempt to do the rewire. So I love Haltech, and they have the software up for free in the base maps that you can download for free. You just need to pay for their hardware. But I mean, the goal should be, if you're trying to save a ton of money and you do all of this and you don't want to buy that expensive wire harness, and you're like, hey, I have wires in the IS300. I'll just wire it in that way. And you do everything that I just did, then you can get the car to start and kind of run on the base map. If you want to adjust it, play around with the fuel, you can. It's a little bit more tricky playing around with the ignition base map because you kind of need a dyno or a ton of log files and driving it around carefully and then having knock enabled so that you can see if the engine's knocking and then adjust accordingly a couple degrees before knock occurs, not just right before knock happens, because you have a little bit of a power decline as you get closer to the knock point. So you want to be a couple degrees away from knock, but that's pretty much it. That's everything that I'm going to cover in this video. I know it is ridiculously long, and I'm sorry for that, but there is a ton of stuff that I didn't want to put into different part videos that I wanted to put all into one video. So thanks a lot for watching. Make sure you like, subscribe, comment, and God bless you guys.